So today we're going to take everything that we learned about graphing and we're going to look at models or word problems and come up with the trig equation to go with it. This is how we would apply everything that we've learned basically to the real world. So have you all seen those paddle boats with the big wheel behind the boat that, back in like the Mark Twain days, right? That's how it moved up and down the river. That's what I'm talking about here. So at 4 seconds, the highest point on the paddle boat is 16 feet above the water. The diameter of the wheel is 18 feet, and 1 revolution takes 10 seconds. So if we have this wheel, right, we know that the diameter is 18 feet. The highest point of the wheel is 16 feet above water. So how much is underwater then? Well, that would mean 2 feet underwater, right? Okay. So if we start at the highest point is 16 feet and the lowest point will be 2 below, okay? The highest point happens at 4 seconds in and completes the full rotation 10 seconds later. So if this is 4 seconds, 10 seconds later would be 14 seconds. And we're back to that high point again. So halfway in between was our low point. Well, what's halfway between 4 seconds and 14 seconds? Well, that's 10 seconds apart. Halfway is 5 seconds, and this happens at 9 seconds. So I'm at my highest point, my lowest point, and back to my highest point again. Now, if this were on your test, okay, I'm kind of thinking my way through. This is showing your work, right? There are a couple things that you could do right now that would automatically give you some points now for writing the equation. Well, what kind of wave is this? Sine, cosine, or tangent? It's the cosine wave. So that's the first thing I need to decide. And if I'm writing a function or an equation, we have y equals, we need the function and we need your x. So that gives you some points. The second thing that I need to look at is my midline. What is the midpoint between these two numbers? Well, think about your wheel. If the diameter is 18 feet, then the radius is 9 feet. So what is 16 take away 9? Or what is negative 2 take away 9? But that's a 7 right there. So my midline shifted up 7, which means I have an amplitude of 9 and 9. So my amplitude's at 9, and I'm shifting up 7. Now, did my graph shift left or right? Yes, it did. How much did it shift? It shifted over to the right 4 seconds. And we know that shifting over to the right 4 seconds means I have a -4 inside my parentheses. Now, the last thing that I need here is my period. If you think about the period, it says that it takes 10 seconds to complete 1 revolution. So if we know that period equals 2 pi over b, we know that the period is 10 seconds. We need to solve for b. So if you want to, you can cross multiply. 2 pi times 1 is 2 pi, 10 times b is b. Divide both sides by 10, and this reduces to pi over 5. So this is my b. Remember, the b affects how to get to your period. Pi over 5. Okay? So we have our amplitude, we have our period change, we have a shift to the right, and we have our midline shift up or down. Now, you could enter this into your calculator, so give that a try, and then I'll teach you a little bit more about the wave. If you put it on your graphing calculator, you should be able to confirm this, or you can use Desmos to help you. So now we can talk about like when things might be in the water, when things might be out of the water. What happens is the wheel underwater or above water at, let's say, 15 seconds. Well, 15 seconds is here, my wheel is above water. Where is the wheel at 10 seconds? Well, 10 seconds is right here, and it's coming back out of the water. So there are different things that you can do then with your graph to understand like where the function actually is. So if you take your first worksheet, and let's look, it's the one that says question sheets, trig graph in context, okay? Let's look at this wave. It's always easiest if you can find one that starts at 0, 0, it goes up, and it goes down, and it finishes its cycle right here. So right now, is that a sine wave or a cosine wave? Well, that's a sine wave. So I already know that my graph or my equation to this graph is going to have sine in it. The second easiest thing, I think, is to find the midline, which happens to be at 0. So there is no plus anything out here. And that helps me find my amplitude. It goes as high as 4 and as low as 4, so my amplitude is 4. It does not shift left or right, so there is no number inside the parentheses. However, I do need to find the period, and it looks like it ends in 8 seconds. So if period equals 2 pi over b, I need to find b. I know that the period is 8, and now I can solve this equation for b. 2 pi times 1 is 2 pi, 8 times b is 8b, divide both sides by 8, and b equals pi over 4. So that is what is going to go inside my equation. Again, you can always test it on Desmos or whatever. So we can answer these questions now. What is the period of the plane's motion? 8 seconds, because as soon as 8 seconds happen, it starts all over again. What does the midway line of the horizontal line represent? Well, if you're looking at a wrecking ball, every time it comes back to 0, it passes the ground and then it swings this way and passes the ground or the resting point and swings this way. So it's your resting point. The amplitude we already talked about, it swings 4 feet this way and 4 feet that way. It says how many complete swings will the wrecking ball make in 4 minutes? Well, now if you wanted to, now you could use your equation to help you do that, okay? This is in seconds, so 4 minutes is the same as 4 times 60 seconds, or 240 seconds. We know that 1 complete rotation takes 8 seconds, so how many will this make? 30 swings. So what I want you to do is I want you to read number 2, and I want you to set up a picture of what this looks like, kind of like a graph. So we have this dolphin, it's coming out of the water and going back under the water and out of the water and back under the water. It says that it goes 4 meters above and 4 meters below. It also says that it completes 1 cycle every 8 seconds. So my cycle right here is finished after 8 seconds. Alright, if you come up with the graph, then you should be able to come up with the equation. My midline did not shift. It has an amplitude of 4. My period is done in 8 seconds, and it is the sine wave. It actually ends up being exactly the same equation as what it was in number 1 because we have the same period and we have the same amplitude. Now, it does ask after 3 seconds, how high above the surface will the dolphin be? So you can use your equation now. X represented time, and you could plug that in for time. And use your calculator. What mode will you be in? Okay, and try that. So I plugged my equation into my calculator. When I hit my graph button, I get that sinusoidal wave, that's what it's called, okay? And I could take my trace button and I could trace it to where X is about, I'm looking for very close to 3, and this is really close to 3 seconds, so somewhere in the middle between 3.2 and 1.8, so right around maybe 2.4, okay, that would give me a good guess. If I asked you where the dolphin was after 37 seconds, well, then we would have to expand our window. So you could go to your window and make your X maximum. We need to be at least 30 seconds, so I'm going to say 35. I'm going to hit my graph. There's the dolphins going in and out. And now when I trace, I'm going to follow my X all the way to around 37 seconds. 37 seconds later, where is the dolphin? 37 seconds, it's underwater, so it would be below the surface. So this is a great reason why you can use your graphing calculator to help you answer some questions like that too. Alright, on your own, try question 6. I will come back on here with the answer. And then in the other worksheet, you will do problems 1, 3, 4, 5, 7, and 9 for your homework. So we have this buoy at 0 seconds at its highest point. It moves a distance of 1.44 meters from the high point to the low point. So I had to cut 1.44 meters in half. Okay? So this is our amplitude. This is a cosine wave. It did not shift up or down. It did not shift left or right. However, the period is in 8 seconds. So period equals 2 pi over b, cross multiply, and b ends up being pi over 4. Again, once you know the equation, you would be able to answer these questions. If you plug it in, the buoy is right around, it is rising at 29 seconds, right around 2.1 meters. And if you're trying to figure out how many times it will go back and forth after 2 minutes, 2 minutes is the same as 120 seconds divided by 8 seconds for every cycle. There are 15 cycles in that time. Okay? It does bounce back and forth every time twice, so technically speaking, it will hit sea level 30 times because it comes back and forth through the up and down. Again, on the other homework packet, the one that looks like this, you need to do the problems 1, 3, 4, 5, 7, and 9. I would highly suggest those, as that will look like something on your test.